Hi, I did a mock interview with an AI interviewer for low-level design of a food ordering system, something like your Zomato, Swiggy, Uber Eats. So if you want to understand like how the conversation actually flows for this question during a low-level design interview, then this video is a must-watch for you. So let me show you how things went. Let's try the question food ordering system, low-level design of a food ordering system. Start the interview. I'm already using Microsoft Edge, so it's good. So once the interview starts, you will see a message from the chatbot or AI interviewer. Yeah, let's discuss the low-level design of a food ordering system. So yeah, let's start. Okay, let me think about all the functionalities. So since this is a food ordering system, so definitely we should be able to order some food. We should also be able to list down see the different restaurants in our area and their menu and basically order food from them. Okay, apart from ordering food, we should be able to see when delivery is getting picked. So we should be able to track our delivery when the delivery person picks it and when they reach our house, we should be able to see it. Also, there can be some functionalities on the admin side, like adding different restaurants on the restaurant manager side. Like they should get the notification when a customer orders their food. There should be discounts, user data management. So exactly what are you looking for? Payment and delivery tracking and notifications can be skipped for now. Right now, we are looking for ordering food, searching restaurants, and rating orders. And you want me to write the method signatures of each. So if we want to order food, so okay, let me write down. So let's order food, and we are going to order it from some restaurant. So there should be a restaurant object, and we will order some maybe one or more food items. So let's have this object and there should be some user ID, some particular user should be able to order food. So basically it's the order details and it will return an order object. So this is what we are going to see for ordering the food. What do you think? Got it, got it. So what do you mean when you say like food or food ID or food item ID is globally unique? So let's do it for one food item rather than a list. I mean, yeah, it doesn't make a difference. So we can make it a restaurant ID, but how would it make a difference? Okay, so for now, although I'm not so convinced, but yeah, let's use the food item ID and user ID, and it will return order ID. Using that order ID, you can fetch the details like the metadata which we gave the restaurant food item user ID. Can you tell me, should we have a separate pay method, payments? Okay, so what should be our next functionality? We should be able to search restaurants, something like search restaurants, and we can give a query or we may not be giving a query, and it can return a list of restaurant objects, or some combination of restaurant and food objects it should return. So yeah, that is there. Okay, so what you want is basically restaurants selling a specific food item and sorted by average rating of that food item. So let's call it food item, food name, and basically we are already, yeah. So maybe you want to return this list of restaurant itself. So yeah, this works fine. Let me just write returns here. Okay, so what do you mean by searching? Okay, so food name. So we can, but we don't know the food item ID. How will that work? Okay, so we are assuming that the food name automatically maps to ID. So yeah, there is that. Okay, so what was the next thing? Rating the order. Yeah, we should be able to rate our order. I think I missed this functionality. So when we are reading, we can use your order ID and then we can use you can see the after apart from yeah, we also give the rating between 1 to 3, 4 and 5 and returns either true false that the rating is updated or not. So yeah, that is there. Okay, so now we are in the class diagram part of it. And so basically listing what classes. So now we are in the class diagram part of it and we need to list the classes which we will need. So certainly I can think of some classes like food item can be a class, then restaurant can be a class. Apart from that, order can be a class, user can be a class, restaurant, since there can be lots of restaurants in the system. So restaurant manager can be there, which will keep track of all the restaurant, and since there is order, so there can be an orders manager. So yeah, restaurants manager, orders manager. So yeah, these are I think the classes that should be in our system, and they are let's keep the search or listing separate. So I think the restaurant manager can keep track of all the restaurants, but let's maybe we will need a separate search module sometime, like maybe we will see if it comes to that. Okay, so how will we like manage and update the average rating of a food item? Okay, got it. So we can have some sort of an average rating class. So that should also do. Yeah. It would be probably with some sort of a basic data class itself. So yeah. No, nothing else is missing. Let's move forward. Okay, so do we need a separate class for managing food items rating? So restaurants will have basically list of restaurant objects. So it will have either a list or a map of, let's just write the basic is some sort of map. It will have some sort of restaurant ID and restaurant object. But where will you keep the search method? Should we keep it separately? This has all the restaurant data. So for searching, we need to basically look for all the restaurants which sell this particular food and then return those restaurants. So we can keep it here, but then it will lead to brute force. Let's keep search separate. Typically, it's a good idea to keep the search separate. Search, let's call it restaurant search. Yeah. Yeah, generally we keep the average rating per restaurant. So average rating per restaurant can be kept in this restaurant manager itself, inside this restaurant manager itself. And like for each food item, that would require some sort of a two-level data structure. So yeah, that we should keep somewhere separate depending on the use case. So tell me what is your expectation? How should we do it? Okay, so we have moved on to the implementation part, ordering food, rating orders, and fetching top restaurants by food item rates. And okay, yeah. So yeah, so ordering food. So we have the order object. So what will this contain? Let me just write it down. Order object will have a order ID. It will, since we are ordering from a restaurant, so it will have a restaurant ID. It will also have a food item ID. Basically, the parameters that we saw in this order food method, and then it will also have some sort of rating between 1, 2, 3, 4, or 5. So yeah, and it will have methods to update rating for a particular order. Let's call it rating. And then we have the orders manager, and here we will keep the order food and rate order method. I think this is a good place. So let me copy the order food here. And then there is the thing about rate order method. So this is where I'm going to keep the rate order method. So yeah, how does it look? Okay, so how will I store and access orders in the orders manager? What data structure will you use? Okay, so we can use some sort of like, we obviously it's a simple map. We can keep something like order ID versus order object and call it orders. So whenever order food is called, we'll create a new order and put it in this map. And on rating order, we'll just using the order ID, we'll just pick the order object and update the rating and we are done. So how does that work? Okay, so you're okay. Can you clarify? Are you talking about average rating for a restaurant, or are you talking about average rating for a particular food item ID inside a restaurant, like a particular food item inside a restaurant? Those are two slightly different things. Okay, so let's keep them in this class restaurant search because this is where we have to implement this method search restaurants also. So the way it is going to work is it will have the data structure. So we can actually keep a two-level data structure. So something efficient would be map of food item ID. And okay, first let's see how the rating will look like. So let's use a basic, so we can calculate average rating by sum by a count. So we can have two variables here. Let's call it long rating sum and rating count and a method get average rating. Basically, you have to return sum by rating sum by. That's what you have to return, and I think this should work. And then also a method add rating, which will take a rating parameter. So yeah, so this is the average rating, and I will then just have restaurant ID and the average rating. So food in a restaurant rating we call it. So this is what it is, and I think this data structure should be enough. So every time what we do is every time we add rating, we call restaurant search and dot update rating. So let's have the method update rating, and it will take an order object. And using the order object, it will just pick the update this maps. Simply pick the average rating object and call add rating there. Okay, so how will fetch sort and top restaurants? Okay, so you want to ask me get top restaurants by food, basically search restaurants. I mean, is it the search restaurant methods you are trying to ask, or is it something different? Okay, so yeah, so what we need to do here is food in restaurant rating map and sort. Okay, so what we do is fetch all restaurants which sell that food item and put them in a sorted set sorted by average rating and then restaurant ID or something like sort them by average rating. That's it. Yeah, so this is a two-level map. So outer map will give us all the restaurants which sell this food item immediately, like in. Yes, yes. So we are sorting only the inner mapping page. This is the thing. This is exactly the thing that I am talking about. Okay, so like, do you want to ask me about design pattern implementation or something? So when a new order is created using order food, how do you ensure that only valid combinations of restaurant ID and food item ID has come? Okay, so we can check using the restaurant manager that restaurant ID is valid, and for food item ID, we can, after picking the correct restaurant object, we can check that that particular food item ID is in their menu. So basically, restaurant manager has list of all restaurants. Let me clarify the restaurant object itself. Let's assume that food item object also had, I haven't clarified that. So it will have some sort of ID, it will have some sort of name, description, price, whatnot. So a restaurant will have basically restaurant ID. Apart from the restaurant ID, it will have list of all food items that it is selling, or we can have something like a map of all the food items, basically, yeah, food item ID versus price. We call this map menu, and price plus availability can also be there. And when you add a rating, how do you update average rating in restaurant search? Okay, so we can have the restaurant search object inside the orders manager, and so we can have a restaurant search this object we can have, and when we rate order we can call fetch and rate order object, and then call search dot update rating from here itself, and call it for order object, and then it will search objects. So yeah. Okay, so let's focus on an updated requirement. Okay, now we have the criteria. So we sorted by average rating. For criteria one, you sort by count of 5-star ratings. Okay, so now we have a separate one thing, number of, so we need some way to keep track of 5-star rating. So are you talking about 5-star rating for a particular food item? Okay, so you are actually, can you confirm that you are talking about 5-star rating for a particular food item ID and not the overall restaurant? Okay, got it. So 5-star rating count should be tracked per food and per restaurant, not overall. So now each food item item, how many 5-star did it get? Okay, so we can keep a simpler, definitely the same map, but now instead of a average rating, we will keep count of 5-star rating. Like, and the thing is, every time the update is there, we can update this data structure also and return based on the criteria. If the criteria is 0, then we return results using this food in restaurant rating map. If the criteria is 1, then we will have a separate method to basically sort the restaurants, since they are both different parameter and different maps. Okay. Yeah, we have both the data structures inside restaurant search. If tomorrow I add more criteria, we will keep adding more maps and logic to this class. Yes. Yeah, that is going to make our class complex because we are keeping all the data structures in the same class and hard to test. Oh yeah, maybe we can use a strategy design pattern here and keep the different strategies in different classes. So we can have like class average rating sort strategy, and basically we are like, let's call it restaurant search strategy. This is our interface basically. So this is our interface, and this interface will have a method search or list top restaurants, and this will have like food item ID, and all the implementers will implement this, and it will return a list of restaurant objects. So both these classes are going to implement this, implement, and There it is, and we'll key, so this is how it is going to be. And another one, we'll have another class, 5-star count, 5-star count sort strategy, and we'll have another method. So so you will use a strategy design pattern, and these will be the two classes, and based on the basically your criteria, call the proper strategy class, restaurant strategy class. Okay, yeah, right. We will keep we also need the data. So let's copy this food restaurant rating data here because it needs this data. But now we have made the data structure internal. So we need to know that how does it update this. So we can use an observer pattern. So these restaurant search strategy, they can be some sort of observers, and our orders manager can be subject, which will have the list of observers, and then it will call the update rating method in each. So we also need the separate update rating method in both of these. So we can have some interface order observer. So we'll have our interface order observer, and it can have a method like update rating, just like we had, and it will take an order object. And yeah, so both these, apart from implementing the restaurant strategy, they can also implement this. Okay, and so they both will have the update rating method here, just like we had in search. So now every time an order is rated, basically update rating will be called from this orders manager. So it will have a list of order observer, and it will notify all auto observers on rate orders. Instead of doing this, notify all order observers. So it will basically call update rating on all order observers using a for loop. Okay, so now the discussion has ended and it is telling me basically how I did. So that's what it is going to tell me. So it will take some time to prepare the assessment and maybe redirect us to the next page. So that's what it's going. It is taking a lot of time. So so now, okay, so first thing is, it is the final assessment. It has given me a first overall verdict. Candidate demonstrated clear blah blah blah, recommend positive. So it's not like very high positive, but it's positive. Then there it could have been negative or partial positive, but it's positive, so it's actually good. So it discusses, then it goes into details of what I discussed and what I missed. So this is how the overall low level design of a food ordering system is going to work in an actual interview. This was all about the low level design of a food ordering system and the main functionalities that you need to cover during the interviews. I hope that you learned something from it. And if you want to try the AI interviewer yourself, then you can do it on mockgym.com. So I wish you the best of luck for your preparation. Thanks for watching.